Welcome back. So this is another past exam question based on implicit differentiation. This is number 2. If you haven't seen my walkthrough number 1, click the tab above or look in the description. This one involves an exponential function as well. So it's worth 9 marks in total. So we should be able to get through this in 9 minutes or less. But let's see what we can do. Take a photo, have a go at it first if you want, and then see if you get it correct. Let's dive in. Okay, start the clock. So consider the curve C defined by the equation, and here it is, e to the power of x plus y is equal to x squared plus y squared, shown on the following diagram. So we have a diagram down here, and it says there's a line of symmetry running through. There are 2 points on the curve, which there are tangents that are horizontal. These points are labeled P and Q. So straight away, we can just define that there are horizontal tangents at P and Q. So that means if we drew a line here or at Q, then the tangent, if it's horizontal, the gradient is 0. So I'm just going to write m is equal to 0, m standing for gradient. So show that the derivative function is equal to the following, and that is an implicit relation. Right, so we're going to take down the original function here. So we have e to the x plus y is equal to x squared plus y squared. And we want to differentiate that both sides with respect to x. So we'll do that now then. So if we're differentiating with respect to x on this side, we have to differentiate with respect to x on this side. So if this is an implicit relation, we need to differentiate e. Now, how we do that is, if you haven't seen my video or my tutorial on this, I also have that linked in the description. So this stays exactly the same. An exponential stays the same. But now we have to times by the derivative of this power. Now, the derivative of that power involves an x and a y. When we differentiate x, we will just get 1. Now we have to focus on the y part. So when we differentiate y, we will also just get 1, but then we also will have to multiply by the dy by dx, because that was the part of the chain rule when we were doing implicit relations, that there you differentiate y, but then you also have to times by dy by dx. So therefore then, we will have to multiply this this exponential function, by all of that. Okay, now on the right-hand side, we will get, so let's just do this now, derivative of 2x is going to be 2x, and then the derivative of the y will be, well, that will be 2y, and then we have to times by dy by dx. Right, now, I want to make dy by dx a subject. So in other words, the things that I'm just underlining in blue here, or turquoise, I want to make the subject. So I'm going to, first of all, we're going to multiply this out, right? So we're going to get e to the x plus y plus e to the x plus y times, and let's use a slightly different color here, so dy by dx. And I'm going to move this to the left-hand side. So therefore, then we'll get minus 2y dy dx, and those two dy by dx's I will need to factor out in a moment, in like factorize them. And if you look carefully here, the 2x is going to remain here, and I'm going to move this in the next line as well, this e to the x plus y to the right. So at the moment it's just the 2x is there, right? So in the next step down, let's move this one to the right, and let's leave the dy by dx's where they are and factorize. So this will be one of our final steps now, dy by dx, open brackets. So we're going to do this one first. So that's going to be e to the x plus y. And now we're going to do this one. So that will be minus 2y, that's factorized now, is equal to 2x. And then I said I was going to move that over to the right-hand side, which is e to the x plus y. And we're getting very close to the result that they wanted. But you need to divide both sides by the entire bracket now. So our final line will be dy by dx is equal to what they required in the question. And we will do a double check to make sure everything has gone to plan. But that looks pretty good to me. There we go. Okay, so 2x minus e x plus y, yes, and then e to the x plus y minus 2y. Yep, so this is looking good. That is part A done. Let's focus on part B now. So B says, show that the x-coordinate of points P and Q satisfy this equation, so the x coordinate. Right, so remember what they said at P and Q. They said that the gradient at those points was equal to 0. So that's really important. And we also proved part A. So I don't even need to go back to part A because we have proved that. So they're just saying that prove that it satisfies this equation here. We have to do this in 4 minutes. So we've got to get a move on. So let's have a look down here. So I've written down the key bits of information. This was the gradient function. This was the original sort of relation that we had. Okay, and this is what I'm trying to prove this really, right? I'm going to try and prove this or show that this is. So in the gradient function then, if the gradient is 0 at that point, we need to either call the numerator or the denominator 0, and it will definitely be the numerator. The reason being, if you call the denominator 0, you'll get something divided by 0, which is undefined, which is not what we're looking for. We're looking for when dy by dx is equal to 0, and that will mean then we need to set the numerator up to be 0. So that will be 2x minus e to the x plus y has to equal 0. And what I can do here is I can move the e to the power of x plus y to the right, and we can take natural logs of both sides now. So taking natural logs of this would equal, now natural log of an exponential will just result in x plus y. And just to the side here, if you're taking natural log base e of e to the x plus y, the base e, what you're saying here is what do we raise the power e by to give us this expression? And the answer is x plus y. So they're inverse relations to one another, so they cancel out. What we could do now, if we have an expression for x plus y there, right, we could actually use that expression in this term, right? Because we can see on the left here that we can have e to the x plus y, and we just found what e to the x plus y is. So what I'll do now is let's just substitute that in. So we're going to get e to the x plus y, but x plus y is natural log 2x is equal to x squared plus y squared. And for the reason I said just a moment ago, these two will cancel each other out because they're inverse operations of one another. But that is a law of logs. I will not go into that just right now. There we go. And now we're getting quite close, really, to what they want us to prove. Because if you look down on the bottom here, they're saying that there is no y terms involved whatsoever. So we need to eliminate all of the y's completely. So if we look at what we've got here, we've got a 2x, we've got an x squared, and then we've got this y squared. So what would happen is if we got rid of this y squared, right? So how would we do that? Well, have a little look above here. We do have a term that can be rearranged to make y the subject. So y could equal natural log 2x, close brackets, minus x. Now imagine substituting this, what I'm just going to draw in a yellow bubble. Okay, imagine substituting this in for y squared. So let's go ahead and sort of start a fresh line down the bottom here. Ready? 2x equals x squared plus y squared. Now y squared will be this expression for y, which is 2 natural log 2nx minus x, all squared, right? So it's very important. The whole thing is squared. Now, if we work our way down here, we're going to have 2x equals x squared plus now FOIL method. So imagine you had two brackets and we're going to times everything out. Okay, first outers, inners last. You're going to get natural log 2x all squared, which is looking extremely like what they were wanting us to do in the result. And now we have to subtract. So in the FOIL method, we would, if you look at this, it would be timesing 2x natural log x, which is one of the other factors, and then we'd have minus x times minus x, which is plus x squared. So that's great because now we're getting the x squared and the other x squared, and we have to equate the entire thing to 0. So we're going to move everything to one side of the equal sign. So 0 equals 2x squared plus natural log 2x all squared, okay, minus 2x natural log x minus 2x, and there we go, stop the clock.
Show's over, motherfuckers.
Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.